This is question 2 from the Conservation of Momentum practice packet. The problem involves two skaters that are on a smooth frozen lake, so we can assume that it's frictionless. We have a skater on the left over here. We're going to call this skater skater number 1, and we'll call the skater on the right skater number 2. So they push off of each other. They're initially at rest. That's given to you right here by the statement that they're stationary. And they give you their masses, and they give you the velocity of one of the skaters who pushes off and moves away. The one on the left pushes off and moves away with a speed of 4 meters per second. And it's important for us to establish a coordinate system when we start this problem. So, if I were to draw an xy axis over here, we would say then anything going to the left on that xy axis would be in the negative direction. This is the negative x-axis, positive x-axis here. So her velocity, the velocity of number 1, is going to be a negative velocity. That's an important thing to see in this problem. Let's go ahead and start this problem like we would any type of a conservation of momentum problem. By the way, this type of a problem would be classified as not a collision, as I'm about to write here, but actually as an explosion. So this is like some of the other types of problems we've seen in class, where the two pieces are basically starting at rest and then separating. So this qualifies as an explosion. And we'll start this problem as we would any of the others by saying that the momentum in the system before this explosion must be equal to the sum of all of the different momenta in the system after the explosion occurs. And furthermore, we can kind of identify each part. We'll say, well, object number 1 has momentum, object number 2 has momentum before the collision, 1 after the collision, and 2 after the collision. However, as I was writing that, you might have jumped to the conclusion, hey, wait a second, the objects are not moving before the collision. That means that their initial momentum of both 1 and 2 together is equal to 0. And that means we have a big fat goose egg over here on this side of the equal sign, meaning that the momentum in the system before anything happens is equal to 0, which means then that after it happens, after this explosion occurs, it also needs to be equal to 0. Keep in mind that this velocity that she has up here means that she's going to also have a momentum since she has mass, but that momentum will carry the same sign as the velocity does. Momentum is a vector. So therefore, the object number 2, which has a different mass but will have a different velocity so that its momentum p is equal to negative p. In other words, this momentum is negative but has to have the same quantity, or I should say magnitude, as this momentum here, but opposite in direction. We'll see that here in just a bit. Let me go ahead and finish this algebraic statement, p1 prime plus p2 prime. Now I'm going to subtract p1 prime from both sides. I get negative p1 prime is equal to p2 prime. And now it's time to kind of separate this into its parts. I get negative m1 v1 prime is equal to m2 v2 prime. And at this point, I know everything, but I am solving for the velocity of skater number 2 after the collision. So I'm going to divide both sides by m2, and I'm left with v2 prime is equal to negative m1 v1 prime all over m2. And now I can substitute some numbers in for each one of these. The mass of skater number 1 on the left is 68 kilograms, so I'm going to get negative 68 kg times the velocity of the skater after the collision, which is negative 4 meters per second as she's going to the left. And then finally, we're going to divide that by the mass of the skater on the right, or skater number 2, which is 56 kilograms. And that's going to be equal to v2 prime, the velocity of the skater on the right after the collision. We should notice here that this negative sign and this negative sign here are going to cancel out, give me a positive number, which is actually what I expect skater 2 to do, because she's going to be going to the right. And so my final answer here will be 4.86 meters per second being the final velocity of skater number 2 after this so-called explosion.